Hello friends, welcome back to my channel. Now in today's video, we are going to look at how to prototype a Scikit-learn machine learning model with Streamlit and how to deploy it to a Kubernetes cluster. So first, you have a machine learning model in Python, and then I'll package it with Streamlit to see how it actually looks like with the UI. And then I'll package it as a Docker image, and then we will test that to be sure that it works locally. Now, once it works, we will push it to DockerHub to store it or also to distribute it to team members. Or now, from the image that we will store in DockerHub, we are going to pull it and then deploy it onto a Kubernetes cluster. And then we make sure that at each stage, the application still is the same and it works as expected. Streamlit is very useful because it's an open source Python library that we use to quickly build and deploy interactive web applications, especially for data science and machine learning projects. So instead of having to write HTML, CSS, or JavaScript code to have some interactive web application, in Python, you can just use Streamlit to make it easier to create an interactive web app for a model. We can use it to create dashboards, visualization, plots, and everything, and it will act something like a web page. So we will do that, and then next we will package it using Docker. Please stick around for the entire video, and now let's start. First, let's look at some requirements here. We need Python, we need a Streamlit package, Docker, a DockerHub account, and we need a Kubernetes cluster. And for that, I'm going to use a Minikube cluster for that. We are first going to start by setting everything up locally. I'm running this tutorial on an Ubuntu system. If I run neofetch, I have an Ubuntu 24.04. Okay. Now, first, we need to install the required packages. So I will run this command here on my terminal. By the way, the commands or the code that I have here is the same thing that's on the GitHub repository. So first, I'm going to update and upgrade my system. Everything is updated. Let's clear the screen. And next, I will need pip to install some packages. So I'll run this command here to install pip. Paste this command. Press enter. I already have it installed. By the way, you need to also install Python. If you want to install Python, just run the same command without the dash pip, and that should install Python 3. Right, since it's already installed, I'm going to create a virtual environment for this project. So I'm going to run python-mvnv env, and that should create my virtual environment. So paste it here, press enter, and you see that it's creating a virtual environment. Okay. And this is a VNV folder right there. Now, if you look at it, it will look like an OS, contains binaries, libraries, and stuff like that. So that's our Python virtual environment. Now, I've set it up, but I'm not actually using it. So I need to activate it. So that's going to isolate everything I'm going to run on my machine in that Python virtual environment. So this source VNV, by the way, this VNV binaries, and it's gonna run this activate script to activate it. So press enter, and you see that VNV is showing here. This means every command we run here or every package we install will be installed inside the virtual environment. Next, we need some packages: Streamlit, Scikit-learn, pandas, matplotlib, seaborn, and report lab. By the way, the report lab is what's going to generate the PDF report. Seaborn, matplotlib, these are for visualization. Scikit-learn is what we use for the machine learning model. In this case, it's a random forest model. And then Streamlit is what we are actually trying to run. So copy this command here, Run it. So it's done installing. Now let's run our Streamlit app. Before we run it, let's go to our app.py and see how the application actually looks like. Of course, you have to import the Streamlit and all the packages that are necessary. Now this is where we load the data. And then we do our split, training and testing split. And we actually do our training here for a random forest classifier model. So this is a classification model. And then we do some evaluation after we've trained the model to see how well it actually works. By the way, the data we are using is the famous iris data. So and now we start with our Streamlit app. This is going to create a page or configure a page and give it this title. And then this st.checkbox. By the way, Streamlit is, we are using a short form st. So whenever you see st.anything, that is a Streamlit being called. This will create a checkbox that we can select or unselect. And that will show the raw data that we have, which is the iris data set. Now this is a model summary for the training, the length of the training sets, the testing sets, the accuracy of the model. Now we are going to create a header model summary with the model summary underneath it, and that is going to also use Streamlit. And then we create a classification report. This will be the header, and then the report will be below it. We also want to generate the confusion metrics with the title confusion metrics from using the Streamlit. And this is going to create a plot for the confusion metrics using pyplot. Next, feature importance plot. This is an importance plot for the features in this data set, just to show which of the features is more important. Next, we'll create a sidebar inputs. By the way, when we generate it, I will show you where the sidebar is going to be on the left side. This is going to create something like a slider where whenever we move one of the features, it's going to predict which type of flower it is, because the iris dataset is about flowers. It will predict which type of flower it is by just moving the slider to the left or to the right, and it's going to be on the left side. Next, we have some prediction results here that we will show. This will be right underneath the sidebar. And then to insert a video, you use st.subheader. This is the title, and then st.video, you insert the video here. By the way, this video is one of my videos on my channel here. If you haven't subscribed, please make sure to subscribe. And that's how you insert a video. I also want to generate a PDF report based on what we are doing. So everything here to the end is basically a PDF report. So I created a function, generate PDF with reports, and it will take all the outputs from the first page. Everything up here is like our first page, and then it will generate the report. So page 1 is going to be the model summary, the classification report, okay, and then page 2 is going to be the confusion metrics image, the feature importance plot or image, and then this last part here is going to generate a button that if I press on, it will download my report. So it's going to create a PDF file. Let's see how to run this. Let's go back to the README. So you run it by running Streamlit run app.py. Clear the screen first. Run this. You can use this command here, copy this, go to your browser, paste and go, and this is the Iris app. This is the video I embedded in it. This is the download button. When you click it, download PDF shows up, and when you click that, it downloads this report, something like this. It's not perfect, but it's pretty cool. There's a model summary, there's a classification report, there's the confusion metrics here, and this is the feature importance graph or image on the other side. Now this is the sidebar that we created. So if I move this, it automatically adjusts everything here and also automatically predicts something like this. Move this down. See, when I move it here, it's now a Virginica. If I move it back, that's versicolor. And it's predicting it real time. And it's also going to be adjusting the data that you have on the side. And this is a checkbox. If I click this, I will see the actual data sets here. If I uncheck it, it will hide it. And our model accuracy is 1.0. Test data set is 45. And our training data set is 105. And that is the model we used. And there is so much more you can do with Streamlit. For us to use it, we have to leave it running. So it will load some logs on here. So I'll open a new terminal that we are going to use next. So let's go back to the README file. Control C to exit out of it. I'm going to clear the screen here. And now when we go to our application, iris, and refresh it, see that it's down. You can close this in the report as well. Next, we want to use Docker to package this application. Now, Docker makes it easy to move the model around or the application around, especially if you pass it to a friend or a team member. So you will build a Docker image out of the app, and I'm going to call it Streamlit ML app, and I will tag it as latest. Now the dot here says use the Dockerfile inside the current directory to build that Docker image. So let's review the Dockerfile and then we will run this command. I'll copy this. So that's our Dockerfile. Since the application is Python based, we use a base image, which is a Python. Now I'm using Slim Bullseye because it's a light Python image. So set some environment variables here. And then we set our working directory. Our working directory, we are calling it /app. Copy the requirements.txt. The requirements.txt contains the packages that we need to install. This is also the packages we installed earlier when we ran it locally. So when we build a Docker image, these also have to be installed inside of it. So we need that. So that will be copied, and then we will install it using pip install this command. And then we'll install it in the Docker image. Next, copy the rest of the files, especially the necessary stuff. Now we don't want a Docker image to be bloated, so you only copy the most important files. Our working directory is /app, so everything we copy, we want to copy it into the /app directory inside the container. Out of the stuff here, we will use the Dockerfile to build the Docker image, but we don't need it inside the container. We also don't need the manifest files. We don't need the license, readme. We basically need only the app.py and the requirement.txt. By the way, we copied the requirement.txt already, so the only thing remaining is the app.py. Now Streamlit usually listens on port 8501, and then this is a command to run it. Remember, when I ran it locally, I used Streamlit run app.py. In a container, this is going to read as Streamlit run app.py, but we need to specify the port number. Now this is server related. That's our Docker file. So in our readme, I'll run this command, paste it here, and this should build our Docker image. Now before I run it, I'll first check the Docker images on my machine. The only image I have currently is the Minikube Docker image. If I run this command, it should add another image. I will paste it, press enter. Now when I try to build a Docker image, it claims that there is some internal metadata that's missing to pull the Python image 3.9 Slim Bullseye. It failed to fetch OAuth token. This error It's usually because I've exceeded unauthorized pool of Docker images. So at this point, I need some authentication in order to pull some Docker images. And so what I would do, or something we would have done later, but we can do it right now, is in the README. Later on, we will push our Docker image to DockerHub, but we need it right now to establish some authentication. So I'll go to my DockerHub account and create a personal access token. And then I'll use that to log in into my DockerHub account. Then we will try to build the Docker image one more time. So go to your DockerHub account. This is my DockerHub account. I'm already logged in. I'll go to account settings, personal access token, and I'll generate a new token. I'll call this Streamlit token. Expiration dates, I'll give it 30 days. Read, write, delete, generate. This is the command to log in. So I'll copy this. And on my terminal, I'll clear the screen for now. And I'll paste the login command here. By the way, the icon C is the username. So in order to log in, we need our personal access token. So copy that. Paste it as your password, press enter. And that should log in successfully. Now that we've logged in successfully, by the way, you can copy the personal access token and save it somewhere safe. Now that we've logged in successfully, let's try to see if we can build our Docker image. Right here, copy this, paste this command here, press enter. And you see that the build is successful. It's going to take a few seconds, so leave it. So it's done. Now, let me clear the screen. When I do Docker images, you see that now we have another Docker image here, which is a Streamlit ML-app, which is the name we gave it when we built the Docker image. So the command we used, this is the name we gave our image, and the tag is latest. That's why the tag here is latest. We built our Docker image now. Next, let's run it to see if the Docker image actually works. And we will do this locally. So use this command. This is going to take the Streamlit ML app latest, this Docker image right here, and run it. And it's listening on port 8501. So we are mapping the port 8501 to that of the container of this application. The port number comes from the Dockerfile. That's the port Streamlit uses, 8501. Press enter for this to run. And this also gives you the commands to use. The same localhost and the port number. Paste it here. And you get the exact same application. This time running inside a Docker container. And everything works. If you squeeze this sidebar, you get a different prediction. You see Sitosa. You move it, Virginica, and stuff like that. If you click the download, you get a download button and it downloads the report. Same as we got earlier on. That's how you would use Docker to run the exact same Streamlit app with this command. So I'm going to exit out of this using Control-C. Clear the screen. These are still our Docker images. So next, by the way, you can use your public IP, especially if you're using a cloud platform, and then the same port number to run it in your browser. Now that you have our image, everything ready, and it runs correctly, we want to push it so that we can store it for future use, or if you want to share it with your team members. And for that, you need to log in into your DockerHub account, but we did that already. So that's good. We already have our personal access token. That was our password we used. But in order to push it, we need to tag our image. So you run this command here, paste it here. Now what this does is take the Docker image that we just built and we just ran, which is Streamlit ML app latest, and then give it your username from DockerHub. So in our DockerHub account, this is my username icon C. So that has to come first, slash the name that you want to give it and the tag. Run this command here. It's going to tag it. Rerun the Docker images command. You see another image, which is just a copy of the previous one. The only difference is the name is a bit different. Image ID is the same, tag is the same, size is also the same. So we've tagged it. Next is to push. So we copy this command to push it to DockerHub. This will just push. It needs the exact username and the name of the app and the tag to push it. This is going to take a while. So the push has successfully been done. Now when we go to our DockerHub account, refresh this page here, and you should see exactly the name. That's the leading one, icon C/ Streamlit ML app. Click it and you should see the latest tag inside here. This was a command we used to push. Now that we've pushed our image to DockerHub, the next thing is to deploy the image that we've pushed to DockerHub to Kubernetes. All right, now to deploy it to our Kubernetes cluster, we first, of course, need to create a Kubernetes cluster. And we use the command minikube start, and then you give it the driver. Now, if you want to specify the number of CPUs or the amount of memory you want to use, you can specify that as well. But for this, I'll just run the command here directly. Clear the screen first and run this. Now, as it's creating, let's review the manifest files we want to use for deployment. So I have a folder here called manifest. Inside it, I have two files, one for deployment, the other one for service. So we review that our cluster is done creating. So if I do kubectl get nodes, that is our Minikube cluster right there. Now let's review our deployment. So our deployment here is called Streamlit ML deployment. We have two replicas for high availability. And the label for our app is Streamlit ML app. And the image we're using is the image on our DockerHub, the one we pushed to DockerHub. It's called icon C/ Streamlit ML app. So that is the exact same name you should see here for the image. And the tag is latest. And the port number for our Streamlit app is 8501. Some resources, memory and CPU to use. Now, readiness probe here is just going to check whether the app is ready or not. So we check constantly in a few seconds every time just to see if it's ready or not. It's going to check the path, which is the home path on our app. Remember when we run it in the browser, we exited it, so this is not working currently, but we use localhost : the port number. This is the same as localhost : the port number /. But everything here is on the home page, and the home page is /. So it will check whether the home page is active using a port 8501. It's going to check it every 5 seconds. And then liveness probe. Liveness probe is just going to check if the app is alive or is actually active. Again, we will check the home path or the home directory to be sure that it's active. Now, it has to be ready for it to be active. So readiness, we check it quicker, like every 5 seconds, but liveness, we check it every 10 seconds. Some environment variable. So that's the deployment file. The service is just going to expose the Streamlit app to the internet. And we are using a node port service, and it's running on, of course, our port number is 8501. But because it's node port, we need to give it some node port number. If you don't give it Minikube or the Kubernetes cluster automatically creates one for you. So this is 3001. So I will apply this. Go back to the README. Since our Minikube cluster is ready, run these commands to deploy. Deployments for this first one. Okay, so the files are inside the manifest directory. So I need to go in there and then run the deployments. This will be created. Next is the service. Run this as well. Be created. Now it takes a while for it to be active. So give it a few seconds. And now we can check the pods, the services, and get the Minikube IP. So let's check the pods first. So it's still creating. Give it a few more seconds. Let's check one more time. And now the pods are running. Remember, in our deployment, we gave it 2 replicas for high availability. So that's why you see 2 pods. That's for the pods. Let's check the services. And that's our Streamlit service running as a node port. And that's the name for it. And that is a port number for the node port right there. Now, in order to access it, we need the Minikube IP. This time it's running in a Kubernetes cluster, so localhost doesn't work. Okay, so let's get the Minikube IP. And now I can copy this. And then with the node port number. So I will close these. They are not active anyways. These were the local setup. So I'll paste the IP address for our Minikube. Our node port is 3001. Copy that. Paste it here and press enter. And that should give you the exact same application we saw when we run it locally. Everything works, by the way. If you move the sliders, see this is Virginica. This changes. The important features changes as you move the slider. And the download feature still is active. You click on this, it downloads the report. And it has the same report. I'll close this. So that's how you would deploy a Streamlit application onto a Kubernetes cluster. Thanks for joining me on this video. Please like, comment, and subscribe to my channel for more videos like this. From time to time, I mix up the videos with DevOps and MLOps, so subscribe to my channel and share it with your colleagues and friends. Now, before we leave, let's do a cleanup. I'll copy this. First, I need to stop my Minikube cluster by running this command here. The Minikube is stopped. Next is to delete it. And you delete it using this command. Press enter. And it's successfully deleted. And now you see that this is no more active. It's done. It's not going to load anymore. All of these are inactive. So that's how you would use Streamlit to deploy or to prototype a machine learning model. Thanks again for joining me on this video. See you on the next one.